I'm happy to be here to present you the work that I did. Well, it was rather like a side project in the past 5 years since I started my master, but it became bigger and bigger. So I'm happy to present it here also to functionality and particularly with a strong focus on the visualization of unstructured grids, because especially at the Max Planck Institute, um, and here at the Helmholtz Center, where we're using Icon and developing Icon, this is a huge challenge for some of our scientists. So just a small technical note in the beginning. So this is a Jupyter notebook, basically, that you can access on GitHub. So if you want to run it yourself, there you find some information. You can also run it on the Mistral supercomputer, and so on. So we start first with importing some libraries. There's no need for that. The outline for today is, first of all, the motivation for psyplot, so why I developed a new framework and didn't stick to the stuff that we had already before, the main features of it, and also an overview on basically the unstructured grids, what means an unstructured grid, and then finally also how you can use the psyplot framework to use it and extend your own data analysis with the functionalities of the package that I developed here. So I'm not a visualization expert in that sense. I'm rather the pragmatic guy in that sense, who just wants to show and generate plots. And this is also the aim for my talk. So my aim is not now to show you the figures that you want to use in your next publication. It's rather for the day-to-day work of scientists. But of course, I mean, all what I show you here today is based on matplotlib. So if you know matplotlib, you can always make the figures publication ready and use it in your for your journal articles. So the motivation is kind of my own story. So Florian already said that I did my master in Hamburg. So before that, I did rarely do some programming at all. So there wasn't much. I had a student tablet together with Stefan Hagemann, and there I mainly had to visualize and analyze climate model output and generate a quick overview that I then pass over to the real scientists, the more experienced people, and they then could evaluate this. So I was, as I said, pretty new to programming, and I quickly lost the overview. I mean, that's I wasn't so good in organizing myself, and it was a lot of copy and pasting. And then half a year later, a new version of matplotlib came out, and all the little snippets that I used don't work anymore. So I said at one point I want to set up a framework basically where I can put all these little snippets separate, but have it in a manner that is flexible, reusable, configurable, and also that I can maintain basically to more and more build up my knowledge and profit from the stuff that I did in the past. I'm really not good with copy pasting. So the question is, why didn't I choose the current tools that we have available, particularly for my day-to-day work with climate models? That was mainly because I'm struggling a bit with the distinguishing the two frameworks here, which is the data visualization and the data processing. For me, this is basically something that comes really together. But if you look into the tools, you have software like ncview, panoply, arcgis, and so on that only focus on the visualization mainly, and then you have data processing libraries from Python, R, such as scikit, scipy, and so on, to do your statistical tests. And There's no real solution available that is easily scriptable and has a graphical user interface and, well, treats this data processing and the visualization hand in hand. So before I start really with the framework and the features, I have a couple of few notes. So as I said, psyplot has been a side project. They mainly developed how I needed it. Since December, I work as a data scientist here at the Helmholtz Center, so I have more time that I can invest into it and more features, but it really grew quite a lot. So I'm really looking forward to gain a bit more contributors to the software and the package. And if you have some snippets you want to share, or if you have some features that you think would be useful to implement, please tell me. And yeah, how to tell me? I'm not on Twitter. I'm pretty bad with social media, which might also be a reason why there are not so many developers for psyplot. But you can always reach out to me via GitHub, or I just set up a new mailing list for psyplot where I will announce new techniques and visualization methodologies, and also, of course, via mail. So there's on the main webpage, you find some information, the necessary links. So this is another point, is that this is research software, and I'm a research software engineer, and probably many of you are also research software engineers, so people who develop software that are made for research. So I'd like to announce you here because there's a community not only with climate scientists but for the entire research area. So if you want to get in touch with other people like you, check this out. And also another general statement would be nice if when you're using the software, you also cite it. It's not only about psyplot, but it's for all research software that is developed, because we do put a lot of effort into making our software sustainable and open source, and it would be nice if this gets also acknowledged in the publications, because otherwise I cannot justify to my boss why I'm still working on the software. So at a glance, what is psyplot? So you can use it basically just as a standard library from Python. So you see here, you can open a netcdf file. This is using Xarray, and basically I just made a wrapper here, just that it puts the boundary variables in the coordinates also. And then you have the variables, like here the temperature, for instance, and you can just visualize this variable with a simple plot method in that sense, right? So this here is now using the triangular grids here. Interesting. Yeah, that's a Jupyter backend. The triangular grids from this icon file, right? So the visualization is pretty simple. So if you just came here to see how to visualize unstructured data, you can leave now. But hopefully you will stay for the remaining of the talk, because there's more into psyplot. So you can also not only generate these plots, but this is also meant to work interactively. So I can also say here, I want to change the color map, right? Then you have the blues here, but you can also do this interactively, basically. You can you can use the netcdf variables and attributes encoded in the data set, and also, and this is something that a little bit breaks the standard Xarray approach, because you can also update the dimensions that you plot here, basically. And then I have also some other format options, like focusing on different regions and so on. Okay. Then the other thing is the graphical user interface with psyplot. So I have basically two frameworks. One is this the GUI that you see here, and then there is another smaller GUI. So I will show it to you, which is PsyView. That's pretty new. And this is basically the same as ncview, just with using psyplot as a backend. So you can open your data set here, and you see here the different variables and so on. And if you ever used ncview in the past, you likely are familiar with these buttons, right? So you can click on the variable here, you can change the color map. With this, you can change even more of the color map. So for instance, we can say here we want to go for 320 or so. You can customize the bounds. You can edit the color map, so like changing individual colors or so on. And then just this updates the plots. And then also you can use different projections here. Yeah, there's a lot of stuff implemented in that sense. Or you can also just hide the variables. You can use different plot methods here. So for icon, you basically want to use this grid cell polygons here, which draws each individual grid cell, which is also then default for such an unstructured grid. What you can also do is if you click on a grid cell, so like for ncview, it opens such a timeline, so you can add multiple lines here with that, and you can also edit these lines. So for instance, when here we have the array name, but maybe we want to rather use the long name, right? So we use here the long name, okay, and then this uses the long name, okay. We want to use, for example, the latitude and longitude also, that should be encoded here. So this is basically taking the data out of the netcdf files, right? And you can use this here in this text labels and stuff like that. And yeah, I mean, you already see it works with unstructured data, but it also works with like rotated poles, so rotated coordinates here in theory. Here we are now. That's why you should not do live coding. So here we are. And then, well, yeah, there you also have the different projections. So it decodes the CF conventions here and does it and interprets it. Then you have the bigger GUI, and I have to speed up a little bit because I want to show you other stuff. Where you also have this PsyView interface, if you like, but you have also a general IPython console where you can just execute standard Python commands. So also here you can make new plots. Okay, you can make multiple variables at the same time. You can specify the subplots here and then select out of the many plot methods that you have and create your plots pretty easily. With this here, with the format options below here, you can update the individual format options basically, and you can also change the time, for instance, so so you can also use here the switch to a different time step in that sense, right? And then you have the variable here. So basically, this data that you select here is a list that is also available here in the IPython console. And then if you just take this here, you have the standard matplotlib data X-array data array, so you can do your own analysis with that as well, and then visualize it again with psyplot through the command line interface. All right, so we come back. These are the main features of psyplot. So now I would like to talk a bit about the grid types that that the software supports for the visualization, which is, I mean, the standard, these rectilinear netcdf files. So here you see an example. You have a two-dimensional variable and one-dimensional coordinate. So I mean, this is supported by pretty much everything. So X-ray supports this out of the box. Matplotlib too, and psyplot of course also. But then it's already getting a bit more challenging with curvilinear grids. So like the MPIOM in that sense, where you have 2D variables and 2D coordinates. So here, this is my variable, and the coordinate lat and lon is here a 2D array, and it may even have 3D boundary variables. So these boundary variables define the corners of the individual grid cells, right? So you have here the standard XY dimension, and then for each corner of the grid cell, you have one longitude and one latitude value. And this is not well supported by X-ray, by the standard X-ray and matplotlib approach, particularly since matplotlib 3.3, because, and I think that makes sense, they changed the default visualization that they now interpolate the grid cell boundaries, right? But for something like the MPIOM, which is the grid that I show you here, where you basically only have data on the ocean and not on the continents, this is not really helpful. So what you want with Matplotlib 3.3, you can still go to the old behavior and like shading equals flat, and then you have the grid cells plotted here. But if you look closer into it, and this is now using the algorithm of psyplot, you see that the grid cell boundaries don't match with what Matplotlib is plotting. So you see a shift here of the variables, and this can become sometimes a bit nasty if your grid cell has then overland and stuff, and you thought it should be over the ocean, and then you think it's a bug in your model, but no, it's actually the visualization. So yeah, but this does unfortunately not work with the standard Matplotlib approach, which is the p-column mesh in that sense. Then we come with icon, unstructured data from icon, which is not supported by the standard Matplotlib and CutPy approach at all. Because there you have a one-dimensional variable, and this has two-dimensional boundary variables, and then you have like three corners for the triangular, or also for the edge grid. You then basically have a four-dimensional or a grid cell with four corners, vertices, and then but the principle is the same in that sense. And the next type of unstructured data is the U-grid, which is a convention on how to store unstructured data. It's a bit more advanced than what we do with icon, basically. So you define such a mesh variable. In this age mesh variable, you have a face node connectivity variable, and this then basically stores. So this is a variable then that stores like which, well, for each individual grid cell, what corner variable this is basically. But this is also supported through through an encoder in psyplot. So you can also work with this. So if you want, there's a more advanced tutorial in the docs also. All right. So let's go back and continue. So the question is now how to visualize these unstructured data and why the standard X-ray matplotlib combi does not work out of the box for this stuff. So one is, I mean, that X-array doesn't handle bound variables. Okay, this bound here should ideally be in the coordinates, because otherwise you lose them easily. I mean, this is something you can fix, pretty simple, but well, if you then want to access one variable, so like the temperature here in this case, you see that it dropped these boundary variables because, and this makes sense of course for X-array, it only keeps the variables, so the coordinates that have the same dimensions as this data array. So that's why in psyplot, basically, you have to access this via this psi dataset accessor, right? So you still have the same data array in that sense, but this then also keeps reference to the original dataset where the latitude and the boundary variables are stored in. So that way, then if you want to plot this here, psyplot can decode, can get these boundary variables out of the original dataset. Okay, the next problem is the map boundary, right? So like here and here and here. So everywhere where you go behind, if you're close to the minus 180, 100, or plus 180, 0 or 360. So this is how psyplot does it. If you would do so in theory, this should work, basically, which would be just a poly collection that draws each individual triangle. But you see that this boundary does not work. And if you look more closely, basically, you get weird artifacts like this stuff here, which are also a result of this map boundary. So this really ruins your plot, and this has been solved within psyplot. Then the other thing is the timing, because visualizing with matplotlib can be quite slow. So I speeded this up. I found a way to speed this up within psyplot, which made it in the end like 4 times faster, which is not so important for this small amount of data that I show here. But if you work with larger and high resolution data, I mean, you don't want to wait 4 minutes for a plot. Already 1 minute is long enough, but I'll come to that later also. So yeah, as I said, this has all been implemented in psyplot, so you can use it for unstructured data. You can change you can use the format options basically that I developed already. For example, change the longitude box mark certain values, update the title with data from the netcdf file. But the question is now, I mean, this is the stuff that I needed, right? So what if you want to do your own thing? And the thing is, you can just make your own plotter, because this framework is is made for being very flexible. So I'd like to give you a short introduction into the psyplot framework, and I'd be happy to chat with you if you have some difficulties, if you want to use this idea behind it and have some questions or how to do something. Because I mean, I'm interested in getting more developers, so I'm interested in that you get more knowledge. So the psyplot data model is somehow illustrated by this graph here. So you have the format option. I start from the smallest unit. You have each format option visualizes one single aspect in your plot, and then you have the plotter that visualizes some data. This data can be either a standard X-ray data array, or it can be a list of these arrays, such as for line plots, for instance. You don't want one plotter for each line plot, but the plotter plots multiple lines. And then you can group many plotters into a project, and then also you have a sub-project, which is just a subset of the larger project in that sense. So from the very low level, basically, you have two main functions. I mean, what you saw in the previous graph here, these things here are all Python objects. So you have the format option and the plotter object. You can define your own format option, which needs a default value. It needs a method how to initialize the plot, and it needs a method how to update the plot. All right, and then you just create a plotter and assign this format option. And just because this class here inherits the format option class, the plotter here knows how to handle this. Okay, and that's it. You can already make your plot. So you already have, you can use your plotter. This here now came through the format option that we just defined. You can turn this into such a project, which is basically just a list. So here you have the data now that you're visualizing, right? As an X array, data array, and you can already update it. You can update it either through this data array accessor with the data that we define here. And here you see again that I'm using this ds.psi, or you can use update it via the plotter or update it via the project. The idea for the project is, of course, that this can handle multiple arrays, right? So this here will only update this one single plot, this here too, and this here too. And this here, in fact, can also then select, handle different time variables with that. So different slices, so you can update it there. All right, and finally, you should always close the project to keep the memory free. Then the high-level interface. So this is how you define the plotters, and the high-level interface is then this psyplot.project.plot.matplot or something like that, right? And this just comes through this registration of a plotter, right? And then you can access it. If you just call this register plotter, you can access it with this myplotter, or you can also access it through this data array, this dataset accessor, and make the plot from there. Okay, so I already made a lot of plugins for this, or some plugins for visualization that have a lot of functionality implemented, like PsySimple, PsyMaps, or PsyReg, where you can also then where they define a lot of different plot methods that you can already use, such as the map plot that I'm using in this example mainly, but also here to do linear regressions or to do like a density plot with an overlaid regression or stuff like that. So there are also examples available on the psyplot homepage. And these map plot things also, they have a lot of format options already implemented. Okay, so to work basically as a standalone thing that you can make the visualization yourself, right? But maybe you don't want this, right? So you already know how you want to set your title. Okay, so there's no need to do this via psyplot. So this is the strength of this modular framework, basically, that you can just extract the format options that you need. So right, these are just all subclasses of format options. You create your own little plotter, specify some default values. If you want, you can turn this into a function, basically. So this here basically just takes the matplot functionality and the format option for this matplot, and then you can use this here to make your own little plot, right? And this then does not have a title format option, or this does not draw a length Z mask or stuff like that. Then some other features of psyplot, you can save and reload these projects, so this then dumps the format options in the plotter and also the alignment of the axis here in that sense, and then reloads it again and regenerates the plot. You can export the plots from that you have in a project, right? So you have this SP again is a here's a psyplot project. Okay, I did close it here in this, but you can use this export method, and then also, well, if you use something like this here, basically it automatically saves it as a with this step 1, 2, 3 thing, and then you have can use the PNG files for whatever you want. Then you can also use it from the command line to generate plots. So there's a psyplot bash command basically, and if you say -o to specify the output, you can save it to some plot. And also if you use you can use some format options here, like here I want a Robin projection, and then this generates an image like that. And this is using matplotlib, so you can do PDFs, SVGs, whatever you want. The next thing is the high resolution data, and this is really something that is difficult with matplotlib. So I mean, so the data processing and stuff with psyplot, this is all not such a big deal. But the visualization, because matplotlib is not made for GPUs, it's mainly on CPUs, and this is really like visualizing a data set like this with 4.4 million grid cells. So it has it's a global data set with about 13-kilometer resolution. Takes a lot of time. So this command here, basically from the command line, it took about 35 seconds, and you cannot work with this interactively. It takes way too much time. Yeah, you can generate some plots. Okay, you may be not. So I don't want to wait that long, but you may agree to wait for 40 seconds to generate your plot. But you cannot work with this interactively. So there are better frameworks available that are not based on matplotlib, and one of them I really would like to invest more time if I have, but unfortunately at the moment I don't have, is to base this all on VTK, like what ParaView is also using, and there's a nice software around named PyVista. And I already made like a proof of concept that you find here, where you can generate such a plot here using PyVista, right? And you can even work with that interactively. So when I can show it to you in the GUI here now. Okay, so we have this. So we have this data set with the 4.4 million grid cells here, right? And then I use this. I use this globe plotter here. Okay. And it takes a little bit, but I mean it's 4.4 million grid cells. Okay, it's okay if it takes a little bit. Okay, it takes quite long. It was much faster. Maybe that's because I'm sharing my screen. But now you can work with this interactively, right? So this is the raw data, the raw icon file with 4.4 million triangles, and you can even use work with this interactively. So you can say data grid equals true. Yeah, my laptop is also as not that patient. Okay, now you have, I mean, it's a black ball, but if you zoom into it, this is also now a bit slower, but these are a lot of lines. You see basically the different grid cells and stuff. So, okay, with the data grid, it's a bit slower, but like with the speed that you have for visualizing this is really amazing. And as we go more and more into high resolution data, this would really be something where you then would have an easy scriptable 3D visualization and and you can use it from the GUI as well. I mean, that would be straightforward to be implemented in PsyView, for instance. And then, of course, you can also use all these general functionalities with, and it also supports the different grids out of the box because it's based on this psyplot framework. So if you want to ever work with, if you have a project in mind, for example, where we could work on this and set something up like that, I'd be happy if you get in touch with me. But so far, I'm pretty much, well, I think I reached my time. So I will end with a summary here, which is mainly about the framework. So the framework for psyplot is that you have this plugins for different types of visualization, and it's really designed to be flexible and sustainable and usable through this graphical user interface. It's based on a NetCDF-like infrastructure, which means that it's not only using NetCDF files, you can also use it with X-ray datasets that you have in memory. And I mean, X-ray supports a lot of backends like grip files or geotiffs and stuff like that. So you all can get this all into it. And then it supports also different grids through this visualization of the individual grid cells. And then, yeah, you can script it, right? So there's there's only a minimum overhead for the visualization, basically. And so you can enhance it with all your scientific analysis toolbox that you commonly use. And that's it. I think I'm done here. Thank you.
Thank you, Philipp. This is amazing. You did what I always wanted to do, but never really found the time to do.